Welcome back to The Explainer. Today, we're diving straight into one of the most mind-bending frontiers in tech right now. We're talking about a breakthrough where artificial intelligence systems don't just solve the problems we hand them, but actually start actively evolving the very environments they operate in. Let's break this down.
To set the stage, check out this absolutely profound quote from the philosopher Henri Bergson. He said, "For a conscious being, to exist is to change is to mature is to go on creating oneself endlessly." Now, Bergson was obviously talking about human evolution and consciousness, but today, we're literally applying this to silicon. We are looking at a massive evolutionary leap from AI just being a tool to AI acting as its own architect.
So here's the core mystery for this explainer. What actually happens when an AI realizes its own flaws and then decides to rewrite the rules of its own environment? And to be clear, we're not just talking about writing better code to solve a math problem. We're talking about the AI changing the fundamental rules of how it's even allowed to operate.
What is an AI harness?
Okay, so before we can understand how an AI changes its environment, we really need to know what that environment actually is. In the industry, it's called a harness. It's the surrounding system, the system prompts, the tools, the memory, the runtime rules that mediates how the AI model interacts with the world. Think of the base AI model, like an astronaut, and the harness is their spacesuit and tool belt. It dictates how they breathe, how they communicate, what tools they can grab. But here's the catch, and it's a big one. If you put 3 totally different astronauts into the exact same spacesuit, it's not going to fit perfectly. They move differently, they have different quirks, and they need bespoke suits to actually do their best work.
Which brings us to a massive bottleneck in AI development right now. Currently, human experts are hand-crafting these harnesses. But manual design? It simply doesn't scale anymore. We're releasing new, incredibly diverse models at breakneck speeds. And different models have entirely different habits, unique flaws, and really distinct ways of messing up. A harness engineered perfectly by a human for one model might completely hobble another. We just can't sit around hand-stitching a bespoke spacesuit for every single new AI that drops.
Section 2, Agents Redesigning Themselves.
So what's the fix? Walk through this progression with me, from left to right. Over in the first panel, human harnessing engineering. That's our current bottleneck. A human scientist with a wrench manually trying to tweak the robot. In the middle, meta harness. This was the next logical step, using a bigger, smarter AI robot to supervise and fix the smaller one. But look at that third panel on the far right. This is self-harness. The human is gone, the supervisor is gone, the AI is literally looking right into a mirror, holding the wrench and redesigning its own parts.
Section 3, the self-improvement loop.
Now, how does a machine actually look in the mirror and fix itself without breaking the whole shebang? Well, the researchers broke this down into 3 totally ingenious steps. Step 1 is weakness mining. The AI looks at its own past failures and groups them together to find specific recurring bad habits. Step 2 is harness proposal. It generates a tiny, highly targeted tweak to its own rules to fix that specific bad habit. And step 3, proposal validation. Because before it just blindly adopts the new rule, the AI rigorously tests it on new problems to guarantee it actually works and didn't accidentally break something else.
Notice how this all flows together into an automated loop. At the top of this flowchart, the system collects failure traces, hard evidence of where it messed up. Then, in that middle green box, the AI steps into a proposer role. It looks at those failures and drafts multiple edits to its own system prompts or tool policies. Finally, down in the bottom yellow box, it runs regression tests. If the fix passes, boom, it merges into the updated harness on the right. It's repeatedly turning its own behavioral evidence into tangible updates, without a single human lifting a finger.
Section 4, Proof in the Data.
Okay, it's easy to talk about AI looking in the mirror philosophically, but does it actually work? Let's look at the hard data. The researchers tested this on a really complex benchmarking environment called Terminal Bench 2.0, and they used 3 totally different base models, MiniMax M2.5, Qwen 3.5, and GLM5. The gray bars here show their success rates with a standard human-designed harness. The green bars, that's the success rate after using self-harness to rewrite their own rules. As you can clearly see, every single green bar is significantly higher. The system adapts perfectly to whatever AI it's attached to.
Just look at this number. For the Q3.5 model, allowing it to rewrite its own harness triggered a staggering 138% relative performance jump on held-in tasks. It literally more than doubled its ability to solve complex terminal problems, just by tweaking its own rules based on its own specific flaws.
And here is the real kicker. It's not just memorizing the test. For the MiniMax M2.5 model, performance jumped an absolute 21.4 percentage points on held-out tasks. These are entirely new tasks the AI had never even seen during its self-improvement phase. That proves the AI is genuinely learning to work smarter. It's actively building a better permanent environment for itself.
Section 5. Fixing bad habits. Let's look under the hood at some actual execution trace logs to see exactly what the AI changes when it fixes itself, because this is a fascinating mini-story. On the left in the red box is a failed trace for the MiniMax model. Its bad habit was that it would get stuck in these endless loops exploring datasets, just reading file after file until it timed out and failed. But on the right, in the green box, we see the trace after self-harness. It successfully navigates the data, computes the tokens, and nails the answer.
So how did it change its behavior? The AI diagnosed its own bad habit and literally wrote a new rule for itself. It updated its own system code to say, hey, identify the required output and create an initial version as early as possible. It also gave itself a hard limit, basically saying, if you hit 50 tool calls, stop exploring and redirect. It forced itself to have the discipline it was lacking.
Here's a second case study with the Qwen 3.5 model. In the red box on the left, Qwen had a totally different problem. When it hit an error, it would stubbornly repeat the exact same failed command over and over. And worse, it would accidentally delete required output files before crashing. But in the green box on the right, the self-corrected model hits an error, immediately catches it, recreates the missing file, and finishes the task.
Its fix was brilliant. It didn't just change a text prompt, it built a custom middleware guard. The AI wrote a script that triggers anytime a tool error happens, instantly forcing itself to check if a required file is missing so it can recreate it. It built its own safety net to catch its own specific mistakes. That is just next-level smart.
Section 6. The Endless Creation.
We are witnessing a truly monumental shift in AI right now. So, to summarize what you should take away from this explainer, we are finally moving past human-engineered bottlenecks. By utilizing an internalized improvement loop, these systems can continually redesign their own problem-solving environments based on their own unique flaws. It takes model-specific weaknesses and turns them into concrete execution rules totally autonomously.
Which leaves us with this final, incredibly fascinating question to ponder. If an AI can now look in the mirror, identify its own flaws, and rewrite its own tools and rules to become better, what will it build tomorrow? Thanks for joining me on The Explainer today. I hope this really helped clarify just how huge this self-harnessed concept is. Keep learning, and I'll catch you in the next Explainer.